All right, so today we're talking about making decisions in VBA. So we'll be looking at several different structures that we use to make decisions, and we'll be kind of giving some exercise on kind of some different little algorithms that we'll be working on. Next time, we're going to be talking about using built-in functions and then creating our own functions. But in today's example, we'll actually be creating our own functions as well. So we won't be talking about all the details involved with creating functions, but we will be doing that. So go ahead and get the book downloaded for today, and then we'll take a look at it. Seems like I've got my VBA window open already somewhere here. There we go. So this workbook is just some data that I downloaded about some books. I don't even remember where I got these books. They don't look familiar to me. Post Alley, the Malamoro King, the Malamoro King. I don't know. Does anyone recognize these book titles? Some eggs or something? I don't know. It's just found some website somewhere. And so we have here then the ISBN number for the book, and then we have some little clip from the like from the actual HTML of the page that renders this. So what does this I and /I tag mean for this little snippet here? Anyone know HTML enough to know what that is? Yep. Yeah, it's just italicizing. It doesn't make sense because that's the title of the book. It's in italics, and then we're seeing a space and then the name of the author. And so it's not unusual to get data from some online site or some online source that needs to be cleaned up a little bit. In fact, it's one of the main things that we do in like data science. It seems like most of data science is cleaning data from whatever source you're getting it. And so a little exercise on that today. Let's go ahead and insert a module into our code for this workbook. And let's start off just by quickly do a loop that will loop through all this data. So we've done this now a few times. So let's just go ahead and make a sub procedure called process data. Dim r as a long integer, r equals 2. Actually, we don't have a header, so r equals 1 to start. Do until, and our sheet here is just called sheet 6. And we'll only have one sheet, so I'm just going to assume that we're on the sheet with the data for today's example. So I won't be specifying the sheet. We'll assume we're on the active sheet. Do until cells, row number r, column number 1, dot value is equal to a 0-length string. Loop. Better make sure I increment r inside the loop. R equals r plus 1, and do events. I'm just going to go ahead and print off those ISBNs. Make sure that I've got my loop working well before I do anything else. We'll run that, should just print off the ISBNs, and looks like it's doing that just fine. Okay. So now what I'd like to do is I would like to look at this ISBN, and I just want to deal with this ISBN strictly as numbers. So in this case, for this particular text, my ISBN has numbers and it has hyphens in it. But I think I would prefer, and we'll often get ISBNs with different kinds of delimiters between the segments of the ISBN. Why does it even have segments? Why are there dashes in the ISBN at all? Do you know? The different parts of this International Standard Book Number mean different things. So this first part says it's a book. This part tells me something about the publisher, something about these two, I think, tell us about the country that it's published and who the publisher is. This then tells us is like the real unique identifier for the book. And then this is a check digit. We'll talk about check digits later in the class. In fact, coming up here pretty soon in the next couple of lectures. So, but that's the reason that it's broken up into different parts, is because someone who works a lot with ISBN, anyone ever work in a bookstore or something where you had to get really familiar with ISBNs? Anyone? No. So someone who knows a lot about ISBNs can look at an ISBN and know quite a bit about that book. And that's why it's segmented like this. But I'm going to say, listen, I just need to work with this strictly as a number. And so I want to write some algorithm here that will take out anything that is not a number out of this ISBN. And so in this case, they're showing the ISBN segments with hyphens between them. It's really common to see them either with dots between them or with spaces or some other kind of character that says, here are the different segments here. Sometimes I see it with slashes. And so I just want to create a general purpose algorithm that will look at a string and give me only the numbers from the string, like throw away everything else that's not a number. So let's go ahead and start by making a function to do that. Now, you're familiar with working with functions directly in Excel. The idea of there being a function inside of VBA then maybe should come as no surprise. So there are lots of built-in functions, but we are now going to create our own function. When we create our own function, it's a special kind of function called a function procedure. So the two kinds of blocks of code that we write in a general module they're both procedures. One's called a sub procedure, one is called a function procedure. And instead of starting with the keyword function sub, we start with the keyword function. So function, I'm going to call this numbers only. Numbers only. And I'm going to send it some text to work with. So remember, inside of the parentheses, whether I'm doing a sub procedure or a function procedure, I can declare a variable. I can declare a number of variables here. It's exactly the same syntax as when I use a dim statement, but because the only thing I can do inside those parentheses is declare a variable, I don't need to put the keyword dim. It's like I don't have to tell the interpreter, by the way, we're going to be declaring a variable here because it's the only thing that's legal inside those parentheses. So in fact, you can't say dim in front of it. It's a special kind of variable called a parameter. And what's so special about it? How does it get its value? How is that variable going to get its value? Go ahead in the back. That's right. It's when I call the function, I'm going to send it some value to work on, and that's going to be received into this variable. And so what I'm going to do is, I'll go ahead and print that off, I guess, but then I'm going to go ahead and call numbers only. So in fact, I think the idea here is I want to kind of build onto this data. So I'm going to write into column 3, just a numeric version of that. So let me just go ahead and say that I'm going to change the value of column 3 on whatever row I'm on. That's going to equal my function numbers only. And I'm going to send it the value, what's holding the ISBN. So the idea here is call this function and give it a value for this text variable to work on. I'm just going to send whatever is in column 1 of the current row. That's the ISBN. I'm send that down in here in text. And then we want this function to send back just the numeric version of that. All right. Now, the truth is, I don't really want this thing to, like while I'm just testing this, I don't want it to run through all, how many do we have here? All 95 ISBNs. One is enough. So let me just make another little kind of debugging function right here. I think we've done this once before. I'm going to call this sub, not a function, it's a sub procedure, my Acme sub runner. Actually, my Acme function runner. And I'm just going to print the result of my numbers only function. And I will just pass it a hard-coded string for me to work on. I'll pick this first one. I think I'll pick that first one. So now, instead of running my whole loop that's looping through everything, I'm just going to, while I'm doing development, I'm going to run this one, and it will call the function just once, passing in that particular string to work on. Okay, show me how comfortable you are with what we've done on the screen so far. 5, 5, 5, 5, 5, 5, 5. Great. All right, so now we need to figure out how we're going to look at this and give back just the numeric values, just the numbers. I want to throw away anything that's not a number. So any thoughts? So, kind of give me an algorithm in English, not in VBA, but an algorithm in English that might allow us to think through how do I accomplish this? There is no function built into VBA that would just do this for us. So we've got to write it up ourselves. So by algorithm, I mean kind of give me a set of steps. It doesn't have to be fully thought out, but we'll go ahead and take it right here. What do you think?
Each character in the string or whatever it is, one at a time, and check if it's like in a list of 0 to 9, and then make a new string with only those that did qualify.
Okay, so I like it. So the suggestion is, let's just look at whatever characters get passed in here. Let's just look at them one at a time. Look at the first one and say, is that in this list, 0 through 9? And if it is, it goes into our new string that we're creating. If it's not, we just skip it. And then look at the next one. And then that'll just give us the numeric results. Excellent. So let's just go ahead and do that. So step one is going to be, how do we kind of look at these one character at a time? And this is like custom made for the for loop. So let me just dim x as an integer. If I say integer, I'm limiting to myself to how long of a string I could pass in. What would be the longest string that I could work with this function if I use x as an integer to keep track of which character I'm looking at? The maximum length of string that I could use is about how many characters? About 32,000 characters. And I don't think I want to limit myself that way, because I can have 4 gigabytes of text. So I'm going to bump that up to at least long, which will give me 2 billion characters. That's a pretty long string. Now I'll say for x equals 1 to the length of the text that gets passed in. And we'll have a next. And then let me just do a debug.print of the mid. These are all both length and mid. These are things we're going to talk about next time we get together. Maybe I should change the order of the way we do these in the future. But anyway, we're introducing some things we're going to look at next time. So mid allows me to look at the middle of a string, look to a particular place in the middle of a string, and then pull out of that string a certain number of characters. So I want to look at the middle of text. I want to look at the xth position and return 1 character. So the first time through this, x will be 1. So I'm saying, looking at the middle of whatever was passed in, look at the first character and give me back 1 character. So that's going to be that 9 right there. The next time through, x will go up. It will say, look at this string at the second character and bring back 1 character. So that's going to bring back 1 at a time. So I'm going to go ahead and print x as well. And then when I run my little subrunner here, we should see, oops, there's the first one, that 98 dash, we can see those right here, 989 dash, 989 dash. So we're seeing the number, its ordinal position, and then we're seeing the actual number itself. Now, I think I'm going to want to do a couple of different things with this. So instead of just working with this, let me kind of put that into a variable. I want to get a variable that's holding just the 1 character that I'm going to be dealing with. And I'm going to call it 1 char, dim 1 char as a string. I don't think I told you this when we're dealing with strings. There's actually a kind of a special way to declare a string. Who can remember how much overhead there is every time I use a string variable? I don't know why you'd remember this if you haven't actively studied it. Go ahead. Yeah, the overhead is 4. So it takes 1 character, it takes 1 byte per character that I'm storing in that string, but there are 4 bytes that just tell me how long the string is. So if I'm using a data type that I say, you know what, I know exactly how long the string is going to be. The string is always going to be a certain length. When I declare that as a string, I can tell it the length that I want it to be by putting a *1 after the end of it. It's kind of a weird syntax. But that says I'm declaring a character variable, and it will always, I'm declaring a string variable, and it will always be only one character because this data type now is a fixed length. I've just saved myself 4 bytes of data. Woohoo, I feel so good about that. But the point is, this is an example of saying, listen, I'm only ever going to put a single character in here, so I don't need a variable length string type. I can use a fixed length string type, and this is how I do it. Okay, so instead of printing that, I'm going to assign it to the variable. So now I'm going to read out of the middle of that one character, put it into one char, and then print one char. Should do exactly the same thing that it did before. That's delightful. All right, so now I'm ready to get introduced to a special case of the if statement. So the if statement, we've seen a couple of times where you say if some condition, then, and then you've got some block that you're going to execute conditionally with an end if at the end. So normally what we've done it is this: if there'll be some condition in here, then end if. And then what executes conditionally is right between the then and the end if. But it turns out there's a special version of this I want to introduce you to, and that is if I only have one statement that I want to run conditionally, then I can do that on the same line with the then, and I don't put the word end if. So I'm going to say if my one character, if it is numeric, and there is a function built into VBA called isNumeric. So isNumeric just returns true or false. It accepts a string argument, and it will return true or false based on if the argument that's passed to it can be converted into a number. So this is a string, 25. Is that numeric? Yeah. Interestingly enough, if you pass something that's actually a number to it, it'll still tell you it's numeric, but it's meant to take a string. How about 25.0? Is that numeric? Yeah. How about 25 point? Is that numeric? Yeah, that's numeric. How about just 0.0? Is that numeric? Yeah. How about just a point? Is that numeric? It's not numeric. So it knows that if it's like fractional number, decimal, even it's like a decimal hanging off the end, still says, hey, that's a number, I got it. But a dot by itself is not numeric. How about a hyphen? Is that numeric? Not numeric. So that will, does a pretty good job. How about this one? Is that numeric? Kind of a tough one. VBA is going to say that's not numeric. I'm kind of glad, actually, that it's because that's a number. That's like the name of a number, but it's not going to convert that one. It's like if it really is a number, that's what it's going to do. Okay, so now instead of doing this print, for every character, I'm only going to do that print conditionally. So before it printed all of the characters in the text that got passed in, including the hyphens. But now, when I'm looking at that character, it's only going to get over here to this part if this is true. So if the one character is numeric, and so those hyphens are not going to be numeric. So when I run this, it should not print the hyphens. And then the numbers, you'll see that we're skipping the number where the hyphen was. So 1, 2, 3, 5, it skips 4. Why doesn't it print the 4? Because the 4 was the hyphen. So it doesn't evaluate in here. Questions here? All right, instead of printing this, what I want to do is just accumulate this. I think the algorithm was look at each character. We're now looking at each character, and we can decide, we can execute code conditionally based on if it is numeric. So now what I'd like to do is I would like to just be able to accumulate that into some other variable. So let me dim a variable called temp as a string. And instead of doing the debug.print of one char here, I'm going to say temp is equal to what it used to be concatenated with one char. So string variables are always going to start out as a zero length string. So the first time through this, we're going to have a zero length string, a string with no characters in it. And we're going to say, we have found something that's numeric, and we're going to concatenate that onto it. So we're going to say the new value for temp is going to be its current value, a zero length string, concatenated on with that 9. The next time through the loop, it's going to go, we found another one. It's going to take temp, give it a new value. What's its new value? Its old value, which is now 9, concatenated on with the 8. And so this should just accumulate that value as we go. So all I have to do now is return the result. And here's how we return the result. So with a function, what we do is we set the name of the function equal to the value that we want to return. It's a weird way. I don't know any other language besides Visual Basic that like uses this convention. Let's set the name of the function equal to what you want to return, but that's the way they do it. And so now when I run this, it's not going to print this off anymore because I've gotten rid of my debug.print, but it should just give me the numeric version of this in the immediate window because I'm printing the result of when I call numbers only and pass that particular number into it. And so that gives me just those numbers. And is that right? 5978, 5978. Yeah, it looks good. So I think now, I think if I were to run my loop, it would actually bring in the numbers only. It would actually kind of bring that into this next column. I'm going to run it and find out if it works. Seems like I should be able to format that. Don't need the commas. What's like just a number? There we go. Number, no decimal points. Okay. First example of the day done. So now let's look at this next one. And let's say, you know what I'd like to do? I would like to get rid of the tags that are in this. So like this, it happens that these are all italics tags. And if this was the only text I had to work on, I'd probably just do a find and replace for the tag, for the beginning tag and the ending tag. But I'd like to write a more general thing that says, listen, I'm going to pass it any string. And if there are HTML tags in that string at all, get rid of them. So let's make another function now called strip tags. By the way, just as a little tip for why you might want to keep track of some things we're writing today is that we've got 2 projects coming up. Our next project is an ISBN validator. So we're going to write a function that allows us to give it some number that purports itself to be an ISBN, and it's going to return true or false based on whether it's a well-formed ISBN or not. And kind of step 1 in that is going to be to throw away everything that's not a number from that ISBN. So this little thing that we've done here is going to be like a jumpstart on that project, if you can remember where it is and find it when it comes to that particular project. Similarly, when we get to the very last project, where we're using VBA to remote control Chrome to go like to a password protected website, log in, download data, we're going to need to be able to get rid of the tags that are in some of the text that we extract from that. And so this, if you can remember that you've got this here somewhere, you've saved this function somewhere, that'll be helpful to you on that last project. That last project, of course, will be due like at the very end of the semester. So anything you can do to speed that one up will probably be great for your other classes too. Okay, so I think the same thing here. Let's go ahead and send some text into this. And maybe I'll put a comment on this one. Remove any HTML tags from the text passed in. All right. Now, we're going to need something pretty similar to what we did with numbers only. We're going to have to look at these character by character again. But now let's think about this. Help me out with an algorithm here. Give me the English language steps of what we're going to have to do to be able to tell when there's a tag and get rid of it. How might we do it? Yeah, go ahead. Okay, so it would be interesting if so one possibility would be to like search for the open tag, and then like the open bracket, the greater, what is it, the greater than sign, the less than sign, the open tag thing is called is the less than sign. So search for the less than sign, and then do what with it? It's definitely going to involve paying close attention to those less than and greater than signs. So yeah, there's not really a way for me to say, just not like built into Excel, say, find anything that's inside of greater than and less than signs and get rid of it. Like I could do a find and replace with something specific, but doing a find and replace with a wildcard character in it, well, it turns out we can do regular expressions inside of VBA. They're a little bit weird to do in VBA, but you can. Anyone, when I say regular expressions, how many of you go, oh yeah, I think I know what those are? Yeah, so if we were to do this with a regular expression, it would be pretty easy if you already knew regular expressions. We don't know regular expressions in this class, and we're certainly not going to introduce those today just to be able to handle this problem. So thinking about the things that we know, like loops and checking for equality and if things are greater than or less than, what might we be able to do? Let's start off by looping through these, like building a loop that will go through this character by character. In fact, I'm probably going to copy like the innards of what we did down in numbers only. I'm just going to copy that whole thing and bring it up here, because we're going to be doing something really similar. We'll look at it one character at a time. We're going to need a temp to kind of accumulate it. We're going to go through the length of text. This part right here, I don't want. And to reset the return value, I'll set it equal, the name of the function equal to it. Let me just go back to, a debug.print of our one char here. So now if I make my Acme subrunner run strip tags and give it one of these strings, then I should get, kind of the same thing we started off before with, just looking at this character by character. So when X is 1, I've got this open tag, then I've got an I, and then a closed tag. And then like the name of the thing, natural pamplemousse. I have no idea what a pamplemousse is, much less what a natural pamplemousse is, but apparently it's a book. Okay, so now as I'm thinking about these character by character, what I do? I'm looking at this character by character. Now, with numbers only, I could just look at each character individually, and I could say, I can look at that character and I can tell if it should be included or not. This one, I just can't look at the character. I could look at the tags and say the tag, like the greater than and less than, don't belong in here. But I can't just look at it and say if it's greater than or less than, forget it, because I'll end up with the guts of the tag coming in too. I'll get the I part of this tag to show up. So what might we do? Go ahead. Yeah, so the idea here is, if you always know it's that the first three characters are a tag, just ignore those first three characters. We've got to, but we're not. You're right. It won't get the middle one, and who knows? But we'll send some data in here that doesn't start with a tag. And so, other thoughts? Go ahead. Okay, so you're saying kind of look at it and tell it to delete something. And how will we know to delete what's inside the tag? Because this happens to be I, but it could be href. I mean, it could be like an anchor tag. It could be a div tag. There could be, HTML tags are all kinds of tags, all kinds of text inside those brackets. So what we got to figure out is we got to have some way to say, listen, to be able to say this character, when we look at this character right here, we need to know that character, not by looking at the I itself, but we need to, by the time we're looking at this, we need to know, what? This is inside of a tag. And so we're gonna ignore it. Because it's inside of a tag, we're gonna ignore it. And when we get to this one, we gotta know that's outside of a tag. So keep it. So the same thing we're doing with numbers only, but with numbers only, we could look directly at the character and know if it belonged or not. Oh. We'll give maybe 30 more seconds of thought about this, and then I will share with you what my solution is. Yeah, go ahead.
That starts when it sees the tag, then delete until you see the close.
Oh, okay. Yes. So what we're going to do is we're going to keep track of whether we've seen an open tag without seeing the closing tag. And so as we're looping through this character by character, when we see an opening tag, we need to do something to say, aha, any other character that we see from this point forward, we're not going to keep that character until what? Until we see the closing tag. And when we see the closing tag, we're going, hey, we're outside of the tag. So we just need some way to be able to tell if we're inside of a tag or not. And so what kind of variable should we use for that? If we're going to have something to keep track of inside of a tag or not inside of a tag, the data type should probably be Boolean. Yeah, so if we had some Boolean variable that we could turn on and off, depending on if we've seen the open tag but not seen the corresponding closed tag, then we could use the value of that variable to decide if we're going to include the character or not. Okay, I like it. So let's give ourselves a variable. Maybe I'll just call the variable in tag as Boolean. Now, in tag, every variable, every data type is going to have a default value. When I make a new string, it's going to start as an empty string. When I make a new integer, it's going to start at 0. What's Boolean going to start as? False. And start off as false. And that's pretty good because before I've seen a tag, I should probably not be in the tag. I mean, I should, am I in a tag? False. I'm not currently in a tag until I find that opening tag. So let's do this. So after we leave the print in there for now, let me just say if, we're going to look at now some different variations on the if statement. If my one char is equal to an opening tag, then I want to do something. What do I want to do? When I see that opening tag, what should I do? Yeah, let's just say that we're just going to set our little value here to say that we are in a tag. So as soon as we see that, let's just say in tag equals true. All right, now else. Have we shown the else before? I'm not sure we showed the else before. Let's talk about what this else statement does right now. So this expression, whatever I have between the if and the then, needs to evaluate to true or false. Got to be able to look at that and evaluate it to be either true or false. If it's true, then we just continue executing until we get to either an end if or an else. If this was true, we execute whatever code is in here, we get to else, and it goes, oh, great, we're done. We hit that else, and we drop to the end if, because everything between the else and the end if should only be executed if this condition is false. So if this condition evaluates to false, then it jumps to the else and starts executing there until it gets to the end if, and then it's done. So these blocks of code are mutually exclusive. Either it's true, either this condition is true or it's not true, and depending on whether it's true or not, it will execute one of these or the other. But let's look at a little, like the next step here is that I can say else if, and I can check another condition. Else if my one char is equal to a less than sign. Then we'll do something different. What are we going to do? Or a greater than. What are we going to do if it's a greater than? Yeah, then we're going to, that's taking us out of the loop. Or, I'm sorry, it's taking us not out of the loop. It's taking us, it's setting our tag. Are we in the tag? Our variable that tells if we're inside of a tag, it's setting it to false. So now let me do this. Let me print. Move my print below this. And I'm also going to print on the end of this in tag. So that should show me the value of whether I'm in a tag after I've processed that letter. And it would help if I actually set this to false. Okay, so when I see this one, after I've seen this one, I go, oh, we're inside a tag. So when I get to this one, I'm inside the tag. After I've seen this one, I'm no longer inside the tag. So all of these that have false should be ones that I should be keeping. So now I'm going to do this. If we have made it to this point, okay, I'm gonna put the else in here. And let's talk about the way the structure works. So now we check this condition to see if it's true. If it's true, we execute whatever code is there between the next word else, and then we drop out. But if this is false, what do? We get to this else if and we go, oh, well, we haven't found one that's true yet. Maybe this one is true. And if that one's true, we execute the code that's associated with it. We get to the else and we're done. By the way, I can have as many else if clauses in here as I want. I can just line them up. And the way it's going to work, it's going to check the first one. Is that true? If so, executes the code and we're done. If not, looks to the next one. If that one's not true, looks to the next one. If that one's not true, looks to the next one. If that one's not true and we're done with them and we have an else clause, then we just execute what's there. So if I ever actually make it to the else clause without having executed a block before it, it says, all right, that's the one we're going to run. And so what are we going to do in this case? We are just going to save that character. So temp is going to equal what it used to be plus our one character. So I'm only going to be thinking about possibly accumulating that character if neither of the tags that we're dealing with, I mean, neither of the characters, the character is neither the opening tag or the closing tag symbol. So I'm never even going to evaluate, I'm never going to get to the else. I should say temp equals temp and. I'm never going to get to this else clause for that character because that character is going to be, that's going to make this condition true. So we'll execute this and drop out. When I get to the I, I'm processing it. It's going to go, is it this character? It's an I. Is it this character? No. Is it this character? No. Well, then I'm ready to accumulate. Now, but I don't just want to accumulate it if it's not one of those characters. I need to put another check in here. What is it? If it's not, yeah, if it's not inside of them, and how can I tell? Like, what's my way in VBA of knowing if it's inside? if in tag. So if in tag is true, then I don't want to keep it. So I'm going to say if in tag is equal to false, then we're going to accumulate. Otherwise, we're not. I think that's going to do it. Are we printing the results of it at the end? I think we are. So now, yeah, it looks right. Natural Pamplemousse by Phoebe Brown. All right. A couple other variations that we can do here. First one is that I want to look at this right here. This thing is itself, this is itself true or false. Like in tag is a Boolean variable. It is either true or false. Now it happens that when it's false, that's when I want this code to execute. And so I'm making this expression, for this to be true, then in tag has to be false. So I get to this statement and it says, if false equals false, then I'll do this. False equals false, is that a true or false expression? False equals false, is that true? And they say two wrongs don't make it right. I don't know how that goes, but false equals false is true. But there's another way for us to get there. And that's like this. Not. So not is a Boolean operation that just reverses whatever comes after it. And so if this is false, and I say not in tag, then this whole expression is going to be true. Yeah, so if I've got some expression equals false, it's exactly the same just to put not in front of that expression without the equals false. This reads a little bit better. If not in tag, yeah, I'm not in a tag, then we'll execute this way. We'll run it and make sure that it works, right? Yeah, it's still giving me what I expect it to give. Tell me which one you prefer. How many prefer in tag equals false? And how many say, you know what, I kind of like the not in tag? About half and half. About a third and a third, and a third of you aren't really sure which way you prefer, and that's okay. All right, but tell me, what would the difference be if instead of doing this as a nested if, so it does make, we should talk about nested if for just a minute. So the point is you can put an if statement inside of another if statement, inside of another if statement, inside. You can nest to your heart's content. But be warned, the human processor can handle about 2 levels of nesting. So as you're looking through this, if you've got things nested 2 levels deep, you're going to be able to understand that code pretty well. As soon as you hit 3 levels, if you're thinking through that code, you need a pencil and to keep track of things, because you just can't keep that much stuff going inside your head at the time. The VBA interpreter it doesn't get confused at all. But you should just be aware that one of the main places that you get errors in code is in deeply nested if statements. That's like danger. It's like a warning flag if you're starting to nest beyond 2 levels. 2 levels is okay. 3 levels, you want to think, is there a different way for me to do this? And is there a way for me to do this without nesting this? How could I do this without nesting that if? So if we think about it this way, I'm going to come in here, I'm going to check to see if this is true. If it is, I execute this and I'm done. If not, I'm going to check to see if this is true. If it is, I'm going to execute that and then I'm done. If it's not, I'm going to check to see if this is true. If it is, I'm going to execute that and then I'm done. Did that sound similar? Did all 3 of those sound similar? So how could I do this one? Instead of having it as a nested if, I could make it a, or I could make it an. Yeah, I could just do it as an else if. I could do it right here on else if, then I don't need the associated end if that's with it. Else if. And so anytime I can get rid of nesting, I prefer to do it. So now that should execute exactly the same way. I mean, logically, it's identical. So I don't have an else clause. Can I do this if, else if with no else clause? Yeah. The else clause is just there to say, hey, listen, if I made it to the else and I haven't put in anything else, I haven't found any of the other conditions to be true, then this is what I do. So it's the same as this, right? Else with nothing in it. That's still legal, but you just wouldn't do that. You don't leave it else unless there's a reason to have it there. And so that's going to be the else if. So let's go ahead and put this one into our code as well. So strip tags, column 4, going to be strip tags. And instead of looking at column 1, I'm going to pass it what's in column 2. So now when I run this, I should get the, wow, why does it take so long to run? It takes a long time to run because of this debug.print that's still in there. Like writing out to the immediate window is kind of expensive. So I'm going to get rid of that and let's see how much faster it runs. Quite a bit faster. It's like it's still printing out this one. Where am I printing that one? Oh, I'm doing it inside the main loop. I think it'll even be noticeably faster at this point. Yeah. Okay, so I just said, hey, let's put into column 4 whatever we get back from strip tags when we pass it in column 2. All right, so at this point, I think I'm ready. Turn left till you get there. Plug in Chris. You got to remember what I did in this example. I'm pretty sure I did something devious in this example. Devious in a way that, it's like something I have run across before. No. All right. Well, let's do one more utility here. And that is, I want to do something called I'm going to call it super trim. And we're going to get familiar with the trim function. Tell me what the trim function in Excel does. Anyone know? So yeah, it's going to remove leading and trailing white space. So we've got some spaces on the beginning and end of a string. You can use the trim function in Excel and it will get rid of those, but it also does something to spaces on the inside of the string as well. So if you've got multiple, if you have multiple spaces on the inside, let's just do it here. Space, 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 high, space, 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 there, space, 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 space. So we'll ask what the length of this is. And the length of that is 28 characters. But if I set this to trim, and we're down to 8 because it has taken off the leading and the trailing spaces. and it's collapsed sequential spaces in the middle down to a single space. There's something pretty similar to that in VBA, also called trim. It does exactly the same thing, except it doesn't touch anything on the inside of the string. But both trim and both versions of trim here deal with spaces. They specifically look for spaces. And I would like to get rid of everything that's non-printable. So what else is like a non-printable character? What else is a character that's like a control character? It's not there for you to see it, but it changes stuff. Yeah. Apostrophe. Oh, in a cell, like a single quote leading it says, hey, this is text. But I mean, just like in a string. If I have an apostrophe in a string, I think I want to keep the string. I don't want to keep the apostrophe. Yeah. Both of those are non-printable characters. So tab and these characters go back to like the days when we used to control like devices for printing just by sending specific characters to them. We don't do that anymore. I mean, it's way more complex than it used to be. But back when we were talking about strings, we took a little peek at the ASCII table. Because the ASCII table is how we convert between, let's go to images. It's how we convert between like the numeric representation that we have to have underneath everything that we store has to ultimately be a number because it's got to be stored as ones and zeros. But if we want to actually get to a character we're familiar with, like capital A, we say, oh, that's character number 65. Capital B is character number 66. Capital N is character number 78. Space is number 32. And that's the very first one that's what we call printable, even though you don't really see that one, it's still a printable character. But all the rest of these 0 through 31, these are control characters. Like if you were to send a 7 to the printer, it would ring the bell on that printer. Like printers had bells on them, like they used to have bells. 8, when you send an 8, what does it do? It moves the print head back one space, like it's a backspace. When you send tab number 9 there, it jumps to whatever its next tab stop is. And how you set the tab stops, I don't know. But here's line feed. Number 10 is line feed that says advance the paper. Number 13 is carriage return that says move the print head back to start printing again. And these 3, tab, line feed, and carriage return, we still use in text files to do just those three things. So we'll actually have like a carriage return character in the text file. And when the text editor reads that, it goes, oh, I get it. It's character number 13. You don't really want to put character 13 here. You want to have the rest of this text happen on the next line down. Because that file, you're working with, is just one long sequential set of characters. It's a string. It's a long set of characters. And some of the characters in there are not for printing. They're to say, hey, where should we be putting this on the page? And when you're dealing with text that you're pulling off of a web page or from some other source, you might say, you know what? I want to get rid of leading and trailing white space, but not just spaces, tabs, carriage returns, anything that's not in the range of my normal characters, which is from 32 up to 127. Anything outside of that range, I would like to ignore. I just want to get rid of it off the beginning and off the end of my string. So let's do that as our third and final example for the day. And I'm just wondering if I've got something in here that's not really a space. There are 2 in there. Let me just check and see. It runs in my mind that I kind of plugged some of these into this file just so that we could do this with them. I want the mid of this beginning at the maybe about the 30th character, taking 1. I don't want to see the character. I want to see the value from the ASCII chart, ASC. That's 101. Darn it. I don't know what 101 is. I guess I could look at it over here. 101 is E. Probably that one. Let's go to 40. 103. Okay, there we go. So I want to go to 41, 2, 3, 4. I want to look at what's 44. That's the comma. 45. It's one of those spaces. 32, 46. Ah, there we go. So there are like two spaces in here. One of those is character number 32. One of them is character number 160. So 160 is up above my normal character range. So 127 goes up to 255. Anyone know what character number 160 is? Yeah. Ah, interesting. So you have found like an extended ASCII chart. Is it on this page? Oh, here we go. Open this one. Open in a new tab. What did I say it was? 160? Here it is. So in the range 0 through 127, those are all standard. From 128 to 255, it's like different depending on the operating system. It's different depending on the way the operating system is configured. And so you can't rely on those characters looking the way that this particular table says that it should look. And so if it was always an A with an accent on it, then we would see that in VBA, but we don't. Because in the way that this is configured, character number 160 is what's referred to as a non-breaking space. So in HTML, if you've got consecutive white space, like in the source of the HTML, when that gets rendered in the browser, all those consecutive white space, whether it's spaces, tabs, entered characters, all gets collapsed down to a single space. If you want to have a space that doesn't shrink down, you make what's called a non-breaking space, and it's character number 160. And so it's really common when you're copying text from a web page and putting it into Excel to pick up these non-breaking spaces. And so it'd be nice to have a way to be able to get rid of not just that non-breaking space, but anything that's a non-printable. And so that's what I'd like to do with this with super trim. In fact, I think what I want super trim to do is I want super trim to just get rid of that character from anywhere, whether it's at the beginning or the end or anywhere in the middle. So let's go ahead and write this function super trim. I've got it already started here. I'm going to change my Acme function runner to call super trim. And I've got that character I'm trying to get rid of is this one right here. That's that non-breaking space. So the same text here will be just fine. And this is going to introduce us into like another way to branch in VBA. In fact, I think I'm going to want to do something really similar. So I'm going to copy the guts out of strip tag. Oops, or numbers only. They're the same. And we're going to start by having the innards of these be just the same as each other. Shrink this down a bit. All right, so I'm going to set the return value. So instead of setting strip tags equal to temp, and I don't want this if because it's going to be different logic in here, but this basic setup is going to be the same. All right. When I have a series of if, else if, else if, else ifs, and they're all looking at the same expression to decide what to do. Now this one, it doesn't. We look at an expression here, we look at that same expression here, but now we're looking at something completely different, right? It doesn't deal with one char on this. And so this is the right structure to use here, because the thing about the if, else if construct is that every single one of the comparisons that I make are independent from each other. They are standalone comparisons, and they could be made up of anything. I'd be checking anything there. But if I have the very common thing where I say I'm looking at one thing, and I want to do something based on what that value is, if it's in this range, do one thing, if it's in this range, do something else, then there's a different structure, and it's called the select statement. And it looks like this. Starts with the keyword select, ends with the keyword end select. 2 words. We say select case, and then we tell it what we're looking at. So this is saying, all right, I'm going to be making several comparisons against one char. We're going to look at one char 12 different ways. And depending what's in that one char, we're going to do something different. So we could use the if, else if structure here. But the whole point of the select case is to jump up and down and say, hey, I'm looking at one variable, and I'm doing something different based on what's in the value of that one variable. And so let's just do this. I'm going to say, so this is getting it set up. And then the way that I decide what to do based on its value is I use the keyword case again, and I put the value in here. So let me put in here. Oh, you know what? I think I want to send this one like after it's been stripped of its tags. So let's take the tags off of this, because I'll be working in the result from what happened with the strip tags. So at this point, let me just say, if it's a capital N, I'm going to do something. And then I'll put that in here, debug.print, found a capital N. Okay, if I run supertrim now, it should only print found a capital N once, because there's only one capital N in here. So why don't we do something that there's more of? Let's do E. I'm going to do lowercase e, because there's quite a few of those. I'll run this. I think I'll run this. I meant to put an E. Thank you. And of course, it says capital N, but it's lowercase e. And I'll go ahead and print X out here as well. So it found lowercase e at the 14th position, the 20th position, the 34th position, and so forth. So if I'm looking for equality between what is in that variable, I can just put it right here. But I can look for like inequality as well. So I can say case is less than 32. And here I will say, oh, not one char by itself, though. I want to look at the ASCII value of one char. So ASC is a function that I give it a character, and it tells me what the number that underlies that symbol is. Found at, let's see, found a small number, small character at X. I don't know that we have any in here that are below. Yeah, so I run that and it doesn't find any that are below. So let me put another case statement in here. I'm going to do case is greater than 127. And here we'll say found a large character. At X. And so I think that will report that number 160. And where was it? It was like at 45, character number 45 or 46. Debug.print, I don't want to multiply that. I want to ampersand it. Oh, so it's finding it at 30 and at 22. I wonder what the character is at 22. It's probably the same thing. It's probably a non-breaking space. Yeah, it's finding that 160 at both of those places. So there's a couple non-breaking spaces in there. And what I would like to do is I just want to get rid of them. So if neither of those is true, then I'll have, like I can have an else clause in my if, else if, else if, else if. I can have the same thing here. I say case else. So if neither of those first two are true, that's when I want to accumulate into temp. So here temp equals what it used to be concatenated with 1 char. So now supertrim should get rid of those non-printable characters. We can see we only have the 1 character between those now instead of 2. So we've got supertrim that'll get rid of anything that's non-printable out of a string. So our last thing to do on this example is just put something into column 5. And what's it going to be? Supertrim, what's there in column 4? So we're taking off the tags and putting it in column 4. We're going to supertrim it. Oops, supertrim. And put that into column 5. So I'll go ahead and run that code. And you can see that that shrinks down between those two because it's gotten rid of those 2 non-printables. All right. We did it all with 3 minutes to spare. Any questions here? So those are like the 2 main things we have are if and then a select statement for doing conditional branching. There are kind of 3 different versions of the if statement. If on one line all by itself, no end if. The block if, which is it starts with an if, has an end if, and you can have else and else ifs included in there. All right, that's it for today. Have a good weekend. I will see you on Monday. Class dismissed.